Hello, this is a lecture for rational inequalities. All right, there are three types of rational inequalities that we'll look at solving. In the first scenario, you have one term and one side equals 0. I'm not supposed to say side. In the second scenario, you have two terms and one side equals 0. And in the third scenario, neither side equals 0. All right, we'll look at the first scenario where we have one term and one side equal to 0. All right, when we have an inequality set up that way, we'll have either a rational expression is greater than 0 or a rational expression is less than 0. Well, if the fraction has a positive numerator and a positive denominator, it's going to be a positive fraction. Likewise, if there's a negative numerator and a negative denominator, the negatives will cancel out and it will be a positive fraction as well. So the fraction is positive if the numerator and denominator have the same sign, right? This fraction will be negative, though, if the numerator is positive and the denominator is negative, or the numerator is negative and the denominator is positive. Or this fraction will be less than 0, negative, if the numerator and denominator have different signs. All right, keeping that in mind, let's take a look at the procedure that we're going to use to solve a rational inequality when one side is equal to 0. All right, the first thing we'll do is set the numerator equal to 0 and solve for the zeros of the function. The second thing we'll do is set the denominator equal to 0 and solve for any excluded values. Thirdly, we're going to mark those values that we found in steps 1 and 2, the zeros of the function and the excluded values on the number line, all right? And then we're going to test a value. We'll mark those on the number line, making intervals, and then we're going to test a value in each interval to see if it satisfies the inequality, right? We're going to check the signs of those test values to see if it satisfies the inequality, right? Once we've decided which intervals do satisfy the inequality, we'll write those intervals in interval notation, all right? One caution here, be careful. You're going to be tempted when solving inequalities, you're going to be tempted to just clear the denominators. You cannot do that with an inequality. That works with equalities because we're looking for specific values. We cannot do it with an inequality because we're looking for an interval of values, not specific values, and we will not get both ends of the interval. We're going to lose one end of the interval if we multiply that denominator away. All right, there's a lot to this. Let's look at an example and go through it a little bit more slowly. All right, here's an example where we have an inequality with one term and one side of the inequality is 0. Okay, 3x minus 10 over x plus 4 is less than 0. All right, to solve this inequality, we want to set the numerator equal to 0 and solve for the zeros of the function. So we'll do that first. So 3x minus 10 equals 0. Add 10 to both sides. And then divide by 3. We see that x is equal to 10 thirds. 10 thirds. Okay, there's step 1. All right, step 2 now says set the denominator equal to 0. These steps are kind of hard to see, aren't they? That's step 1. Here's step 2. Set the denominator equal to 0 and solve for any excluded values. Okay, so let's do our step 2. The denominator is x plus 4. If x plus 4 equals 0, when we subtract 4 from both sides, x is negative 4. All right. Now, step 3 says we want to mark these values, the 0 of the function and the excluded values. We want to mark those values on the number line to establish our intervals, our possible, our solutions, the intervals that are possible solutions to this inequality. All right, so step 3, we'll make a number line, and let's mark those values on there. All right, let's see, we've got x equals -4, so we'll say maybe -4 is here. 4x is 10/3. That's about 3.3, a positive 3.3. So we'll say 10/3 is up here. It's definitely bigger than -4. Okay, there's our values on the number line. Now we have intervals that we can test, right? We have intervals that we can test. One interval will go from -4 off to -infinity. Okay, another interval will be between -4 and 10/3, right? And then we have a third interval, all values greater than 10/3. 3 intervals, right? So we need to pick, so that was our step 3. Now, step 4 is we want to pick test value in each of those intervals, and we want to test the signs to see if it satisfies the inequality. So what does that mean? Well, let's pick a value. In the interval, in this first yellow interval here, why don't we use -5? It's a smaller value that's in that interval, right? So we'll test x equals -5. Okay, so when x is -5, my numerator is going to be 3 times -5, or -15 minus 10. That's going to be a negative numerator, right? So I don't care what the value is. I'm just going to say it's negative. I don't have to be that careful to know what the exact value is, because if I get a negative over a negative, this is going to be positive. But if I get a negative over a positive, it's going to be negative. And I'm testing to see if it's negative in this less than 0. So that's what I'm trying to figure out. Now my denominator, if x is -5, -5 minus 4 is -1, so that means my denominator is also negative. Here I have a negative over a negative. They undo each other. That makes it a positive. So that value is not, I repeat, that value is not less than 0. It's not less than 0. So that means this gold interval here, is not an interval that we want. This interval does not satisfy the inequality. It does not satisfy the inequality. All right. So what we're doing here, we're actually doing our step number 4 here. We're testing those intervals. Right. We'll remember that number 4. All right. Now let's test the purple interval. Let's pick a value in there. -4, 0 is in there, and 0 is always a very good value to test, right? It's a very good value to test because it's easy to calculate, right? So we'll test x equals 0 here. All right, with the numerator, if x is 0, the numerator is 3 times 0 minus 10, or -10. That gives us a negative numerator. I'm trying to see if it's less than 0 or negative. If when x is 0, 0 plus 4 is positive, that gives us a positive denominator. And a negative numerator divided by a positive denominator is going to be a negative value. So that means this purple interval is a good interval. We want to keep that interval. That is going to give us a solution here. If one test value works, they will all work in the interval, right? And then this one last interval here to test. Let's look at this pink interval. A test value here. If 10/3 is about 3.3, why don't we use x equals 4 as our test value? All right, we'll test x equals 4. If x is 4, then 3 times 4, that's 12 minus 10, that's positive 2. That means my numerator is positive. When x is 4, 4 plus 4 is positive 8. That means my denominator is positive. A positive over positive, is that less than 0? No, it isn't. That's going to be positive. Positive over positive is greater than 0. So this last interval, this pink interval here, is not one that we want. It does not satisfy our inequality. So our solution then is going to be all the values between -4 and 10/3. Okay, and since Since our inequality was less than 0, not less than or equal to 0, we want to use parentheses to bound that interval. So we want to exclude those n values. Okay? Let's do another example. This is pretty complicated. There's a lot of steps. Here, let's go back and look. Write in interval notation. That was our 5th step. To write it in interval notation. And that, of course, was what we did here, our 5th step. All right, let's do another example. Okay, this is still the first type of inequality. We have one term. It's a rather complex term, but it's still one term, and it's less than or equal to 0. All right, this is going to be much easier to deal with if we factor it. So let's go ahead and factor the numerator and factor the denominator first. Okay, so when we factor it, let's see, that numerator is going to factor into x minus 4 times x minus 7. And the denominator will factor into x plus 3 times x plus 3. Okay, and that's going to be less than or equal to 0. All right, so now we want to go with step 1. Set the numerator equal to 0, solve for the zeros of the function. So if x minus 4 times x minus 7 is equal to 0, the zero product principle tells us either x minus 4 equals 0 or x minus 7 equals 0, which means when we add 4 to both sides in the first equation, x equals 4. When we add 7 to both sides in the second equation, x equals 7. All right, so there's my 2 values for that. Step number 2, set the denominator equal to 0 and look for excluded values. All right, well, if x minus 3 times x minus 3 equals 0, I'm sorry, x plus 3 times x plus 3, that means x would have to be what? Negative 3, right? Because x plus 3 equals 0, or x plus 3 equals 0, which means subtract 3 from both sides, x equals negative 3. All right, so there's my 3 values. Here's my boundaries, 4, 7, and negative 3. This is what I want to mark on my number line. All right, so here's my number line. This time I'm going to have more intervals to test, right? Let's see, negative 3 is the smallest. So we'll put negative 3 there. Then comes 4. Then comes 7. Okay, now I have 4 intervals that I'm going to test, right? 4 intervals that I'm going to test. Let's see. So that was step 3, marking the zeros on my number line. Now step 4 is to test these intervals. All right, this first interval will be everything less than negative 3, right? Let's test that interval first. Test x equals negative 3. All right, if x is negative 3, what happens to my numerator? We're going to use the factored version. It's easier to deal with, right? Negative 3 minus 4 is negative 7. Negative 3 minus 7, that's another negative. A negative times a negative makes it a positive. So our numerator here would be positive, okay? And negative 3 plus 3 is 0, 0. So what does that mean? Here my denominator is 0. We can't have divide by 0. Oh, because I didn't use the right, I need something in the interval to test, not at negative 3. I'll need to use negative 4 to test, because we never want to test the boundaries because the boundary was actually a 0 in the function, right? So it's negative 4 that we want to test, right? Negative 4 minus 4 is negative 8. Negative 4 minus 7, negative times a negative, that's still positive numerator, right? When we test our denominator, negative 4 plus 3, that's a negative 1 times a negative 1, that makes that a positive denominator. Positive divided by positive is not less than or equal to 0. This is on an interval that we want. It does not satisfy the inequality. Let's go on and test the next interval. Negative 3 to positive 4. What value should we test in there? 0's in there, and that's an easy one. So let's test x equals 0. Okay, if x is 0, the numerator is -4 times -7. That's positive numerator. The denominator is 0. It's 3 times 3. That's positive 9. So we're positive over positive. Again, this one is not less than or equal to 0 either. So this is also not an interval that satisfies our inequality. All right, let's move on to the interval between 4 and 7. Let's use the test value of 5 in that interval. So we'll test x equals 5. Okay, when x is 5, 5 minus 4 is positive 1. 5 minus 7, that's negative 2. Positive times a negative makes that a negative numerator. The denominator is 5 plus 3, 8 times 8 is positive. A positive numerator over, a negative numerator over a positive denominator is less than or equal to 0. So that's an interval that satisfies this inequality. Okay, we want to keep those values. We have one last interval over here to test. Here's a color I haven't used yet, orange. So we'll test that interval. Let's use 8 as our test value there. So when we test x equals 8, let's see, our numerator is 8 minus 4. That's positive 4 times 8 minus 7. That's positive 1. Positive times positive is positive. So a positive numerator. The denominator, 8 plus 3, that's 11 times 11. That's positive also. A positive divided by a positive is not less than or equal to 0, like we want it to be. So this interval does not satisfy our inequality. We need to throw that one away. All right, so that was our step 4. Now our step 5, our last step, is just to write these intervals in interval notation. Okay, the only interval that's good is this green interval here. So the solution here then is going to be between 4 and 7. Do I include those boundary values? Well, as long as they don't make a 0 denominator, which neither one of them does, because it's less than or equal to 0, I do include them. So I want to use a square bracket. I want to use a square bracket around the solution. All right, so we said at the beginning there were 3 types of inequalities that we were going to look at. The first type was when there was one term and it was equal to 0. And the second type that we were going to look at, there they are again, is when there's 2 terms but one side is equal to 0. All right, so let's see. Let's look at what we're going to do with that. We're just going to turn that into the first type. We're going to combine the 2 terms into one term, and then we'll just use our procedure for solving an inequality when one side is equal to 0 and there's only one term on the other side. All right, so here's our example. 2 terms. First term is 8 over x plus 6 minus the second term, 7 over x minus 5, and it's greater than 0. All right, so we need to combine these 2 terms into one, right? Or we need to subtract these rational expressions, and then we'll solve the inequality. So recall that to add and subtract rational expressions, we need to have the same denominator. We need to establish a common denominator. And the way that we do that is by multiplying, find the least common denominator, and then convert each fraction or each rational expression to one that has that denominator of the least common denominator. So first, let's find our LCD here. Neither of these factor, and they're not the same, so our least common denominator is going to be x plus 6 times x minus 5. Okay, now this first term, this is going to be the denominator I need to establish. Well, there's an x minus 5 missing in the denominator of the first term, so I'm going to need to multiply the 8 over x plus 6 by x minus 5 over x minus 5. Okay, and then the 7 over x minus 5 is missing the x plus 6 in the denominator, so I'm going to need to multiply that rational expression by x plus 6 over x plus 6. Okay, and that's going to be greater than 0. Okay, now I've established the common denominator. And my denominator here now is going to be x. I could say either x minus 5 times x plus 6 or x plus 6 times x minus 5, because multiplication is commutative, right? Doesn't matter the order I write them in. But the numerators do matter because I'm subtracting the second from the first. So this is going to be 8 times x minus 5 minus 7 times x plus 6. Okay, that's greater than 0 still. Let's simplify that numerator a little bit. Okay, let's distribute that 8 and that negative 7. So we'll have 8x minus 40 minus 7x, and then negative 7 times positive 6 is negative 42 all over x plus 6 times x minus 5 is greater than 0. And then combine the like terms. I can simplify that numerator further. 8x minus 7x is just x, and negative 40 minus 42 is negative 82. So we have x minus 82 over x plus 6 times x minus 5 greater than 0. And I'm going to leave that in its factored form, because when it's factored, it's going to be much easier to test for positives and negatives. Okay, now that I've combined, this is one term, it's a complicated term, right? The numerator is a binomial. The denominator is actually a factored trinomial, but it's still just one term. It's a rational expression. Now I can go back and I can use my steps when there's one term and one side is equal to 0 to solve this. All right, so first we'll need to look at setting the denominator, or numerator, sorry, the numerator equal to 0. So if x minus 82 is 0, adding 82 to both sides tells us that x equals 82, all right? And then the denominator, we have x plus 6 times x minus 5, so either x plus 6 equals 0, which means x is negative 6 when we subtract from both sides, or x minus 5 equals 0, which means x equals 5 when we subtract from both sides. So there's my three boundaries, negative 6, 5, and 82. Okay, so I've done step 1 and step 2 now. Now I'm going to do step 3. I'm going to mark these zeros and excluded values on the number line. All right, so here's my number line. There's my number line. And let's see, we'll say negative 6 is here. 5 would be here. 82 is out here somewhere. We'll just mark it there. All right. So there's my step 3, mark my zeros. Now I need to do step 4. I need to pick some test values and check the signs on the numerator and the denominator to see if they're going to be positive. Since this is greater than 0, I'm looking for positives. So let's see, we'll say our first interval is pink this time, pink interval. So the test value we'll use here is negative 7. So when we test x equals negative 7, let's see what happens. Where are we? Let's simplify for a second. So negative 7 minus 82 makes a negative numerator. Negative 7 plus 6 is negative 1 times negative 7 minus 5, negative 12. Negative times negative makes that a positive denominator. And I'm wanting this to be greater than 0, but it is not greater than 0. It is not, right? So that means that's an interval that does not satisfy our inequality, so we throw that interval out. Okay, now let's move on and test the next interval from negative 6 to negative 5. Let's pick 0 as our test value. That's an easy one, and it's in that interval, right? So test x equals 0. The numerator would be negative 82, so we have a negative numerator. The denominator would be positive 6. Me a negative value, so we have a negative over a negative. Is that greater than 0? It is, right? Negative over negative turns it into a positive. So this is an interval that does satisfy our inequality. All right, let's move on and test the next interval from 5 to 82. I guess we use orange for that. Let's pick 6 as our test value in there. So we're going to test x equals 6. Okay, my numerator, 6 minus 82 gives us a negative value. My denominator, 6 plus 6, that's positive 12. 6 minus 5, that's positive 1. Positive denominator, well, that is not greater than 0, right? A negative over a positive divided by a positive is going to be a negative. So this interval doesn't work. I don't want that. That's not going to be part of my solution. All right, one last interval here to test. That's everything greater than 82. Let's use 83 as our test value in there. So we'll test x equals 83. Okay, 83 minus 82 is positive 1 over 83 plus 6, that's a positive. 83 minus 5, that's another positive. That's a positive over a positive. That's definitely going to be greater than 0. So there's another interval that satisfies our inequality, right? So our last step here then, our step 5, is to write that interval as an inequality, or to write this interval in interval notation. There's 2 of them, right? There's 2 intervals. The first one is negative 6 to 5. And let's see, it's not greater than or equal to, is it? So I'm going to use parentheses. The first interval in union with my second interval is everything greater than 82, or 82, 82, that's a 2. 82 to infinity, never reach infinity, gets a parenthesis. Again, not or equal to, so I want a parenthesis by the 82. Okay, any values in these intervals will satisfy this inequality. Okay. What happens when we have an inequality that neither side is equal to 0? Well, if neither side is equal to 0, move everything over to one side, combine all the terms to one term, and then we can follow our same procedure that always works. Follow our same procedure that always works for one term that and one side equals 0. All right, let's look at one last example that's in this third format, right? This third format that we talked about in the beginning, where neither side is equal to 0. All right, so here we have 3x minus 10, 3x minus 10 over x plus 4, and it's less than 2. It's not 0, so I need to make that side 0. Let's subtract the 2 from both sides, right? Then we have 3x minus 10 over x plus 4 minus 2 is less than 0. There. Okay, so now we made it 2 terms with one side 0. Now we need to establish a common denominator so we can combine these into one term, one rational expression. All right. Well, our least common denominator here is x plus 4. So that's the denominator that we want to establish. All right. Since the first term has it, I only need to multiply the second term by x plus 4 over x plus 4. Let's do that. We have 3x minus 10 over x plus 4 minus 2 times x plus 4 over x plus 4, less than 0. So now our common denominator is going to be x plus 4. My numerator is going to be 3x minus 10. Let's simplify. Let's distribute that negative 2. Negative 2, so minus 2x, because negative 2 times x is minus 2x. Negative 2 times 4 is minus 8. Less than 0. Let's simplify that numerator a little bit more. 3x minus 2x is x. Negative 10 minus 8 is negative 18 over x plus 4, less than 0. All right, now we've got one term on one side, 0 on the other. So we can go ahead and set the numerator equal to 0 and the denominator equal to 0 to establish the boundaries of our intervals. What if we just do it down there? If the numerator is 0, this gives us the zeros of the function, right? We add 18 to both sides, we see that x equals 18. If the denominator is 0, this is our excluded value, right? Value, well, it's just 1. X 4 equals 0. Subtracting 4 from both sides, we see that x equals negative 4. There's our boundaries, all right? Step 3, let's draw our number line and mark our boundaries for the intervals. that might be solutions to this inequality. Okay, we'll say negative 4 is here. We'll say 18 is here. And we have 3 intervals that we're going to test. Okay, well, at our first interval, be everything less than negative 4, let's use negative 5 as our test value. All right, so test x equals negative 5. So let's use our simplified version down here. Negative 5 minus 18 gives us a negative numerator divided by negative 5 plus 4. That's a negative denominator. Okay, is a negative over a negative result in a negative? Nope, negative divided by negative is a positive. So this first interval is not less than 0, so it does not satisfy our inequality. Throw that one out. Okay, let's test that next interval between negative 4 and 18. 0 is in there. So that's a good test value. It's always easy. So if we test x equals 0, let's see, our numerator is going to be negative 18. So that's a negative over divided by. Our denominator is going to be 0 plus 4, positive. A negative over a positive is going to be a negative, right? It is less than 0. So that's an interval that satisfies our inequality. We do have one more interval to test. Let's test it. This last one out here. We'll choose 19 as our test value. Do it over here. I wrote too big. Test x equals 19. Okay, x is 19. 19 minus 18 is positive divided by 19 plus 4. Positive divided by positive is not less than 0. So that interval does not satisfy our inequality. Throw it out. Okay, last step is to write our solution in interval notation. Good intervals that satisfies this inequality is between negative 4 and 18. Negative 4 and 18. It's not less than or equal to, so I'm going to go ahead and use parentheses around that interval. Okay, this ends the lecture on rational inequalities.